Hey friends, we're back here on the workbench with the 70s Fender Princeton Reverb project here. And I think what we're going to do is, within reason, try and remove as much wax as possible, focusing primarily on the areas where we've got the pot connections to the board. So we've already confirmed that none of the other pots are really making any noise when they're moved. The biggest issue we had last episode was the reverb, which had quite a lot of DC there, and we're still getting some DC in the board, which is crazy to me because it is completely clean of any wax now after many layers of isopropyl and naphtha here. So how to get rid of that, it's really just got to be heat, I guess, and removing components. And to be honest, it's just going to take an exorbitant amount of time to do that. I don't have the time, and I would have to charge quite a bit because there's just so much time invested in this. So instead, we're going to focus on being smart and economical here. Still doing a good job, but yeah, just trying to be a bit more strategic about it. And yeah, so with that in mind, we're going to be trying to clean, all of these connections, this white, black wire right here. We'll go over this one more time. These connections right here, this connection right here, the bias supply. So kind of making sure those are all good to go, and there's as little wax as possible around those eyelets, and also cleaning out those eyelets, hitting them with the soldering iron again just to make them super fresh. Probably lift the leads out, so I can hold the soldering iron on there to really cleanse the area, and then put it back. But yeah, we're gonna go ahead and do that and see how it goes. But I think that'll set this amp up better for the long term, and is within reason, not gonna be too difficult. So let's go ahead and get started. It's probably just gonna be a time lapse for you guys because it's gonna take probably, I don't know, close to an hour, I would guess. So, all right, let's get started, and hopefully you guys will see me in about 10 seconds. All right, cool. All right, I said it was going to take an hour, and we are, 55 minutes in. So there you go. It looks far better. Obviously, there's still some wax here and there. Like I said, we could spend at least another hour really doing it. We'd have to lift all of the components, completely take everything off the board to really get all of the wax under every little piece. But overall, it looks quite a bit better, and I'm sure we're going to not have any issues with errant DC in any of the eyelets where it will matter going forward. So I'm pretty happy with that. So now what I'd like to do is go ahead and finish up the screen and grid resistors here. So as it was pointed out to me, and I later realized, the wires need to be moved around a little bit to actually make this mod work. I've never done it before to an amplifier. I've obviously worked on amps that have it already, specifically the screen and grid stoppers on the power tubes, but a Princeton doesn't have that. And I didn't catch what was needed to actually make them be active, more or less. So we just got to move around a couple wires. Super simple. Same thing with here with the phase inverter. We've got a wire going to the same same eyelet and the same pin here, and the resistor should be replacing that wire, not in addition to the wire. So we'll take care of that, and then move a couple wires around here, and then we'll be good to go to fire back up. So the first one we're going to tackle is just removing this wire right here. Not a ton of room to reach this eyelet, so we'll try and be careful here. Airplane grade or something covering shielding I put on this resistor is quite resistant to the heat from the soldering iron, so not really worried about that. More all of these other very fragile wires Fender used back in the 70s. Beautiful. So there's that. Let's put that aside. And then we'll touch up this solder joint here since we just disturbed it. And we'll do the same on the pin. All right, that one's done. Now let's go ahead and move over to the power tubes here. So I added check marks here because I already added the screen and grid stop resistors here. So you guys saw those in, I think it was part 3 of this series. So let's go ahead and look at the connections. So we'll start on the left here. So we've got pin 4 should just be the lead of the resistor, and pin 4 actually has a wire connected to it. And so this wire, you'll be able to see it, but this white wire right here that I'm pointing to is also connected to pin 4 of the other other power tube socket. So we want to disconnect that and disconnect this. So both ends of pin 4 are isolated from each other. And then we are going to be moving this to this wire to pin 6, which doesn't currently have any connection to it. So let's go ahead and decouple that from the tube socket pin real quick. All right, so that's done. Let's look back at the layout here. So we moved that connection from pin 4 to pin 4 to pin 6 to pin 6. And then pin 6 should have another wire connected to it, which is going, I'm not sure if we'll see this or not, but so pin 6 should have now this wire going over here to the high voltage, this middle eyelet of the 3. So there's already a wire going to that middle eyelet of the 3, but that was connected to pin 4. So we're going to do the same thing and move this one over to pin 6. Okay, so let's just quadruple check everything we did here. So these are good to go. Yeah, good to go. So now for the grid stoppers here, these little 1.5Ks we added across, was it pin 1 and 5 of both tubes. We've got this wire and this wire both going to either of these 220Ks. This needs to be moved from pin 5 to pin 1 for both of those. So it's going to be tricky because there's not a ton of room. And of course, this is going to be a nightmare this side. So if we lift that up, we should be able to reach it, but let's go ahead and move forward. Well, it looks like this is not long enough to reach, unfortunately. So we're going to have to remove this wire and replace it with some cloth wire. So that's okay. Let's go ahead and do that. Not too big of a deal. Annoying, but not the end of the world by any means. This one I don't think we'll be able to reach either, so we'll just replace both. All right, since we did so much work there, I want to go ahead and fire it up again and just make sure everything is okay. So we will connect it to the current limiter just to be extra safe, make sure I didn't mess up anything. And then, yep, we'll just give it a quick little play. And then I think we'll end there for tonight since it's already pretty late. But we made some good progress. I think we're good to go as far as any leaky DC on any of the eyelets. And now these are all, I guess, quote unquote, activated. So yeah, that kind of leaves one last mod for this really, which is just the mid spot. But like I said, I want to get it more dialed in with the stock tone stack layout before we dive into that and see how that sounds. So, all right, let's go ahead and get it set up to be plugged in. All right, so let's go ahead and check it real quick. So we got it plugged into the current limiter, which is then plugged into the Variac off screen. I've got the multimeter hooked up to the bias control. It should read in the -37 to -40 range, the current limiter in chain. And yeah, I just want to do this real quick. We'll see if the light bulb lights up to show some catastrophic issue. I don't think there will be. Slowly turn up the Variac. All right, 120 volts right there. And the amp is dead silent. I have the cab next to me, don't hear anything, which is great. And yeah, like I said, we're getting about negative 37 volts DC for the bias, which is kind of right what I would expect with the current limiter. So now that's checked, let's go ahead and turn it off. We will unplug the current limiter, plug it directly into the wall, and then yeah, let's just do a quick check of the knobs, make sure there's no scratchiness to them, make sure that's all fixed, and then what should we do after that? maybe we'll check the reverb, and we'll put in the cab and check the reverb real quick too. So, all right, let's go ahead and flip it off. All right, we're plugged directly into the wall. Let's turn it on. I'm expecting the bias to be a bit higher without the current limiter in chain. And yep, we're up to negative 39, negative 40, which is where we were before. So that looks good to me. Now, again, amp is dead silent. So it seems like we did fix that kind of, you guys heard the sound on the last. Oh, I do hear a little bit, actually. One sec. All right, so that's still an issue we'll have to figure out. To be honest, I'm kind of leaning towards the 100Ks here. That could be an issue. Could also be a tube, actually, because these are the original 12AX7s. So the 12AT7 was swapped, as that was a bad tube. Yep, the rushing water noise is getting a bit louder now. Okay, so we'll try and swap some different tubes in it. But first, let's just confirm that we're good to go as far as no DC on the pots, no scratchiness. Nothing. 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 This was the really bad one. Nothing. Nothing, and this one also had some. Nothing. Okay, we've cured that issue. So that's good. Grid stoppers, screen, resistors are all good to go. So now let's go ahead and, how about this? Let's go ahead and put this in the cab. We'll put the cab probably up here on the workbench. I don't know how much you guys are going to be able to see just because of the way my camera is set up. But we'll plug it into the reverb tank, see if the reverb is working okay, and play with some tubes. And this will be very ad hoc, not anything great as far as a guitar playing demo is concerned. But we should be able to learn a lot doing that. And then from there, we can kind of figure out a game plan for the next series of tasks outside of the mids pot, which will be kind of the next major thing. However, I want to make sure that this amp is totally solid before we dive into any mods like that to the tone stack. I just want to make sure everything else is sorted before then. So, all right, let's go ahead and cut here, and then we'll put it in the cab and go from there. All right, so we've got the amplifier back in the cabinet here, screwed in, just so I can kind of show you guys and hopefully let you hear the testing I want to do with the tubes real quick. So in it right now are all of the original tubes that the amplifier came with. So all of these vintage RCA preamp tubes, with the exception of the 12AT7, which, as I mentioned before, was completely dead. And so in it right now, the owner provided two, let's see, they are Jan GE 12AT7s. So some new old stock or vintage tubes here. And so I put one of them in this position, V2, which is the reverb driver, I believe. And yeah, so we're going to go ahead and turn it on. And let's see if we get that kind of crazy, staticky, poppy, rushing water kind of noise or not. Because I want to determine if it's tube related or it's something in the amplifier itself. And we will also try and narrow down where it is based off of the tubes we pull out. So first and foremost, let's just go ahead. We'll point the microphone down at the speaker here, turn it on. I'll have the volume off so that it's we're not worried about any of that. There's nothing plugged into it. This is purely just the amp itself. Now there is some background noise. I don't know if you can hear that. We've got the heater running in the house. I'm in the garage next to the heater there, so it is giving some ambient noise, but I'll try and gain up the mic and point it directly at the speaker so you guys can hear exactly what is going on. So with all of that, let's go ahead and turn it on. I'll point the mic down. So hopefully you were able to hear some of those pops. It's really not ideal right now. The ambient noise in here is quite loud, but hopefully the mic was able to pick it up okay. So there's definitely some pops going on and some of that kind of loud background noise. So I think what we're going to do is I'm going to pull V1 and turn it on again and see if it stays there. And then we will pull V2 and kind of go through and kind of try and isolate where the noise is coming from. and it could be a tube or it could be something in the circuit in that area, and then we'll start changing some tubes and seeing if that fixes it. So we'll pull V1 here. Now, one thing that we did note from before is that it kind of did it in the first minute of turning the amplifier on, and once it warmed up, it kind of went away. So that's why I don't want to just leave it on here for a long period of time. I kind of want to just identify the noise while it's happening, let it cool down for a sec, and then turn it back on. So, okay, we've got V1 out. Let's go ahead and point the mic back down and turn it on. All right, I'm not convinced the mic is going to be able to pick that up the way it's positioned right now. There's just too much noise in here, but I hear the noise level is still quite loud as it's warming up there. Lots of kind of background hum and hiss, and a couple pops here and there. So I think pretty conclusively it's not V1 or anything in the V1 area. It's after that. So I'm going to try, what do I want to do here? Let me try and position the mic a bit better, point it straight down at the speaker to see if it'll pick it up a bit better. I'll turn it back on, and then if it looks like I'm getting better levels, then we'll move forward with swapping a tube. So let's do that real quick. All right, I'm going to leave the mic where it is, and we're going to go ahead and pull V2. Hopefully you guys can hear me okay. So we're pulling V2 now. This is the 12AT7 that we replaced. Let's turn it on and see if we're still getting that. All right, I don't hear anything, at least nothing that's jumping out to me over the, again, very loud noises in this room already. But yeah, I don't really hear anything. So to me, that seems pretty conclusive. It's somewhere in this area of the circuit and or that tube. Now, just to be safe, he provided two different 12AT7s. They both look identical, but let's go ahead. We'll put V1 back in because we know that's fine. And let's swap this to the other one he provided and see if that makes any difference. So pretty obvious there. Immediately there was noise and issues and pops and whatnot. And this is with the other provided 12AT7, this vintage Jan GE. So just out of curiosity, I have a couple, I don't have any new 12AT7s on me, but I do have a couple vintage ones that I have laying around for a different amp. So let me grab one of those and swap it in, and let's just see if it is completely the tube. Maybe, I mean, I don't know what the chances are that both of those tubes are bad, but more likely the circuit, probably the plate resistors or something. But just out of curiosity, let me grab a couple of those tubes and we can try them real quick. Super interesting. It sounds like the noise floor is way lower now. It's hard to tell again, but that definitely seems to have improved things. Let me turn it off and switch back to one of the other provided tubes just to make sure it's not just because things have warmed up enough. So let me go back to the tube we were with previously. So back to one of the provided tubes. So interesting. Okay, let me grab one more of my 12AT7s and compare just out of curiosity. Super fascinating. Hopefully that came across okay, but it appears that actually both of these Jan GE 12AT7s that were provided by the owner for this amplifier are bad. So both of them were super noisy and had popping noises. I've never actually heard of those noises associated with the tube before, so that's kind of fascinating to me. And then the one that came with it, let me grab it real quick. So this was the tube in it, and I actually remember commenting it was clear, and I was really confused by that. Now I know this actually just lost vacuum, it appears. So this one was completely dead. I actually had a JJ that had a similar thing, and ended up looking clear like this. So I guess that's a sign of it losing vacuum. And yeah, so this one was completely dead. So unfortunate, all three 12AT7s with this amplifier are bad, but the good thing for the owner is that 12AT7s are very cheap if he doesn't have any more. So no big deal there, but I think we solved that problem pretty conclusively. So for now, we'll keep mine in it. This is already earmarked for a different amp, but we'll keep it in here as we continue to work on the amplifier. But awesome, that actually makes me really happy. It seems the amp is running really good otherwise. So sweet. What next? From here, I kind of want to just play around with the amp a little bit, run it for some time, and just make sure everything is good and solid. Make sure nothing pops up. You know, it hasn't been played much in its life, so you know, it being on for an hour might reveal some things, for example. So I definitely want to do that tomorrow. But as long as it has good tubes in it, it appears to be pretty healthy, which is awesome. I think we're going to go ahead and end there. Thank you so much for watching, guys. Really, really appreciate it. And yeah, stick around. We'll finish this out probably, I don't know, in a week or so. And I've got a bunch of other projects, including some really cool old vintage amps like a Silvertone, an old Gretsch, and then, of course, my catalog of amps that still need some love. So subscribe, give this video a thumbs up, comment below what you think, share it with some friends, and until next time, I'll see you guys.